Hey everybody, it's Mike Meyers and Richard Chapman, Two Ball Nerds, coming to talk to you this week about, and our topic is defense in depth. As a matter of fact, Richard, I know that that's a big issue for you guys at the enterprise level, and I've actually got questions for you, Richard, about defense in depth. Um, I mean, first of all, I understand conceptually what defense in depth means, and we even have a Two Bald Nerds video where we talk about conceptually what defense in depth means. But when you're thinking about defense in depth, what does that mean to you?
So it means that we are looking at all the possible ways that somebody can gain access to our network. And we're trying to ensure that we have protections in place that are as autonomous as possible, that will automatically be blocking activities that we don't want threat actors to be able to carry out.
I mean, the challenge I run into when we start talking about defense in depth in IT is, if we're talking about defense in depth, again, Richard, I always do this. I imagine shells, right? Like,
Yeah.
Good old Niels Bohr chemistry shells. Remember those?
Mm-hmm.
Before those pesky quantum mechanics guys messed everything up. But so a lot of times the question I run into with IT is, what are these shells? What are these 2, 4, 18, chunks? Because, this is where frameworks really come into play. And I know NIST does an interesting job on this type of stuff is, the function of a framework is to make you start thinking about how we're going to do something. That's what a framework is.
Right.
And maybe it gives you a couple of basic forms or some graphics to help you on your way. But so to me, if we're going to have defense in depth, Richard, we're going to have some kind of framework, and that framework's going to have to manifest as, I'm assuming, shells.
Yeah.
Does something like that exist?
Yeah, and I would say that the frameworks are absolutely, kind of a how-to. If you have no idea of what you need to do, then it absolutely can give you the how-to on where you need to begin and what you kind of need to do to set up the protectionary levels for your network. It really kind of is a how-to. So it is helpful in that regard. We've talked about the whole graphic, and as a matter of fact, I've got a graphic that I can share with you, which kind of does look exactly like what you're talking about, almost like that bullseye kind of mentality, where you have kind of a layer inside of a layer inside of a layer, and that's not exactly accurate, because in realistic perspective, they're kind of separate individual components, but you still have to have protectionary levels for those items that are still inside of your network or outside of your network for that matter, if they're in the cloud, which is a whole other dynamic, right? Not just talking about on-prem activity, but cloud stuff as
I
well.
agree. So where is this? Well, first of all, well, show me, will you?
Well, yeah, I'll show you.
I'm very
So
intrigued by
let me
this.
see here. Let me share my screen. You guys should be seeing my nice little
Ah, here we
slide
go.
there.
Is this a Richard
So
Chapman original here, or what are we looking at?
no. This is a rip off and duplicate. Um, just because honestly, it's already out there. Why not use what's out there? But this is a good logic to kind of start your process when it comes to protecting your network, right? And again, it does kind of look a little bit like a bullseye, where you would think that the data is at the center of the whole thing. That's not really exactly how it is, but you do still think of it in kind of these terms. That first layer there, your network or your perimeter, is really, again, primarily your first main line of defense. Setting up a good firewall, having proper architecture with DMZ, maybe a secondary firewall for where your data servers might be if you're on-prem. It really just depends on exactly what your network looks like and how the architecture is. But in the grand scheme of things, all of the devices that communicate in and out of your network have to be behind at least some sort of network protectionary measure. And that's where that initial perimeter comes into play. So it is kind of like what we talked about in the previous video. It's that wall,
Sure.
it's an initial wall to protect everything. But just because you got that wall doesn't mean that necessarily you've got you've got automatic protection against everything inside of that network. Host protection, which is the next one on the list here, that's a perfect example, because you have to be able to look at the endpoints themselves, because there are activities that can be introduced to an endpoint inside of that network that's protected by the firewall that the firewall can't do anything about. So it's not that the firewall fails in its job, it's that it's a totally different situation that the firewall is not designed to protect. So layered defense is a lot of that. It's a lot of protecting things that you don't have one tool that protects everything. So it's protecting things that this tool can't protect. You know what I mean? Does that kind of make sense a little bit?
Yeah, no. My only challenge to any form of framework like this is that we visualize we have a network of computers, and inside this network are all of our hosts, right?
Mm-hmm.
And
Yep.
inside each host are applications, and inside each application is data. And I mean, you can certainly say that, but this is where you get in trouble, because the data can be outside all of these, right?
Yeah.
Then how granular do you get? Like, to me, the outer circle ought to be the internet, and then have your networks within the internet, so this is an old argument, Richard. I don't want to drag you into the latest iteration of something we've been yelling about for almost 30 years. Is what is the it's those
Yeah.
who can't teach, right? So yeah, we had fun talking about the circles.
Well, I do think that one of the reasons why the graphic does still work is I think that the protectionary measures are a little more broad scope in the network protection and the perimeter type defense. And then you get a little more focused with the endpoint protection. And then you get a little bit more focused with the OS or operating system and the application security with vulnerability management. And then you get really, really focused with the data management. So I do think that in that regard, the graphic is still pretty accurate. But you could almost draw a big circle and say this is our network, and then have multiple circles within that larger circle, right? Not nested within each other, but separate entities inside of that overall network, because that's really what it looks like, is your overall network, which includes on-prem, cloud resources and so forth. They all encompass your attack surface. So that overall graphic is probably one big circle. And then you have individual circles inside of it, so there are individual focal points within that larger circle.
Sure. So now, Richard, did you do number 3 and 4?
So no, so OS and app security, that's really focused on making sure that we're not leaving any vulnerabilities that an attacker can take advantage of.
So this is more,
firewalls.
hold on, Richard. This is more like developmental security stuff.
So
Okay.
yeah, so for instance, your firewall, especially if you have a next generation firewall and you've got a really good IDS system like FortiGate firewall with a built-in IDS, it is really good at being able to see signature-based attacks, where attackers are sending well-crafted headers, maybe they're doing SQL injections and so forth, which take advantage of vulnerabilities in web applications or even just applications and hardware you have in your network. And if there's not that level of protection, let's say it's a 0-day vulnerability on an application or a piece of hardware, your firewall is not going to do anything. And unfortunately, your vulnerability management there is not going to do anything with a 0-day. But if you have a lag in that process somewhere, maybe there's not a patch available, but the firewall does a good job of creating a rule to identify that malicious header or something to that effect, then it can step in and protect at that point in time. But if for some reason the firewall does miss a signature-based attack, then hopefully your vulnerability management is in check so that all of your applications and hardware are patched. They're up to date. They have the most up-to-date software available, which usually means they're the most secure. Usually, not always. Sometimes new patches create new issues, right?
Very true.
But again, it's a possibility for it's a wrinkle, and attackers can sneak in through these different wrinkles and so forth. And the more protection you can have there, the better. And it just eliminates. It creates a smaller percentage of attack surface that is vulnerable to those attackers.
So then, Richard, compare OS and app security versus number 4, your data information protection for me, would you?
Yeah, so you've got the application itself, the program. You have to be able to make sure that the program is safe and secure, that there's no security flaws in the programming that would allow an attacker to take advantage of that system, whether it be your operating system or an application running. But the data is a totally different situation. That's, like your PII, right? Your personally identifiable information, data that you do not want attackers to be able to have. As a matter of fact, whenever you hear about a big breach, that breach usually means that data has been, exposed, and the attackers now have data. They've been able to gather social security numbers and addresses and phone numbers, dates of birth, whatever data, they've been able to grab there. So you do have to focus on the data storage, encrypting that data so that even if they do gain access to it, they can't get it. It's encrypted in a way that does not allow them to easily see it. Let's put it that way. So it is a totally different and separate component from the vulnerability management that you do on the programs that run on the machine.
Gotcha. All right, so let's wrap this up, Richard, in that understanding these framework bubbles like this, folks, these are not dictates from on high, all right?
Yeah.
They're just tools to help you understand a concept so that you can put it to use. So you're actually allowed to disagree with Richard's 4 bubbles here: network, host, application, and data, as long as you can talk about it. And that's what frameworks do, is that they allow administrators to talk to each other and organize and design amazing networks that are secure.
Absolutely.
Cool. Richard, this was a good one. I've always liked the defense in depth concepts. And I almost could do this one more time. I don't want to do, we have so many good examples like EDR and stuff like that already. We simply repeat ourselves. But that's very cool. Richard, thanks so much, man. Let's do this again sometime.
All right, sounds good. Have a good one.
Bye. If you like Two Bald Nerds, check out our entire playlist right here. It's a lot of fun. We'll see you there.